simpler than you think, so let's get started.
What's the goal of CCA? It's all about understanding the relationships between different sets of multivariate data. When there are too many combinations of variables between data sets, it's hard to tell the relationships. We want to reduce the combinations while preserving the original variable relationships so we can understand them easily. What are relationships anyway? They are the correlations between variable sets. What we need for joint understanding. The stronger the correlations, the clearer the relationships, and the more information it holds. What does it mean to reduce the number of variable combinations? It means creating new variable sets by combining the original variables. Instead of analyzing many individual variable pairings, we combine them into a few variable set pairings. So what is CCA really? It's a way to create new variable sets that have the largest possible correlations. This makes it easy to understand relationships between data sets using just a few variable sets. That's CCA, Canonical Correlation Analysis. Create new variable sets with large correlations. Understand relationships with fewer variable set pairings. Canonical Correlation Analysis. Reduce variable set pairings and conquer multivariate relationships. Uncover the hidden associations. It's the power of CCA. How do we create these new variable sets? Let's call the original variable sets x and y vectors, and the weights for combining them ui and vi. Then the new variable sets are ui transpose x and vi transpose y. How do we calculate the correlations? The correlations between new variable sets are covariance of ui transpose x and vj transpose y equal ui transpose sigma vj. Give them the variance of each new variable set is 1, where the ij element of this matrix is the correlation between new variable set I and j. How do we maximize the correlations? We can do this by performing singular value decomposition on the correlation matrix sigma. We look for the directions where the correlations between variable sets are strongest. Those directions are the weights ui and vi. So what is CCA really? It's a way to look at the relationships between data sets from a new perspective. A perspective that makes it easy to see the correlations. That's CCA, Canonical Correlation Analysis. Create new variable sets with large correlations. Understand relationships with fewer variable set pairings. Canonical Correlation Analysis. Reduce variable set pairings and conquer multivariate relationships. Uncover the hidden associations. It's the power of CCA. The directions for creating new variable sets are the singular vectors. These are all orthogonal to each other. The correlations are the singular values. They are sorted from largest to smallest. If you want to understand the relationships with fewer variable set pairings, just keep the new variable sets with the largest correlation. Canonical Correlation Analysis. Create new variable sets with large correlations. Understand relationships with fewer variable set pairings. Canonical Correlation Analysis. Reduce variable set pairings and conquer multivariate relationships. Uncover the hidden associations. It's the power of CCA. Canonical Correlation Analysis is a powerful tool. It's the key to understanding relationships between multivariate data sets. Now you're a data scientist too.